Yeah.
Namaskar, Saurav ji. Saurav, Dr. Saurav had been contacting.
Okay.
Yeah. And,
Yeah, Saurav and Javed. Javed, how are you?
yes.
Fine, sir. How are you, sir?
Yeah, I'm fine. Thank you.
Yeah.
So,
Namaskar ji, Javed sir.
Good day, everyone. The technical session 2 on hydrometeorology will start now. This session will be chaired by Professor Dr. Deepak Ariel, Head, Central Department of Hydrology and Meteorology, Tribhuvan University, Nepal. And this session is co-chaired by Professor Dr. M. Shahjahan Mondol, Director, Institute of Water and Flood Management, Bangladesh University of Engineering and Technology, Bangladesh. I'd like to request Honorable Chair and Co-Chair to evaluate all the presenters according to the prescribed format and send us as soon as possible. Now, I would like to request Session Chair and Co-Chair to start and conduct the session. Thank you.
Thank you very much, Javed. And I would like to welcome Professor Mondal here. I think one of us will take care about the time, and one of us will invite the speakers. In this session, we have, according to the schedule, we have 6 presentators or 5. 1, 2, 3, 4, 5. 5 presentators. So without making any delay, once again, welcoming in the session, I would like to start with Drought over India, Present and Future from Majumdar. Your time is 20 minutes and Professor Mondal will take care about the time. He will alarm you in 15 minutes.
Yes, sir.
According to the organizer's schedule, after 15 minutes, we will allow 5 minutes for the questionnaires.
Yes.
So let's start. Majumdar, once again, nice to meet you and welcome you in this special session. Please, now turn is yours. Please go ahead.
Thank you. Thank you, session chair and co-chair, sir. Today I will be presenting droughts over India. My co-authors are Professor Dr. B. Preeti, Dr. Ramarao, Dr. Bhupendra Singh, Naresh Ganeshi, Mangesh Goswami, and Dr. R. Krishnan. So from Center for Climate Change Research, CCCR, IITM, Indian Institute of Tropical Meteorology, my associate and me, we are studying some cases over droughts over India, and I shall be sharing those some experiments what we have carried out, analysis what we have carried out, and diagnosis. Let me first acknowledge Professor Tohida Rashid and Professor Abdul sir for giving me this opportunity, and at the same time our director also for encouraging me to participate in this ICMCS 2020 Dhaka University event. So to begin with, first let me share a few slides about our activities here. So this is the open access book, Assessment of Climate Change over the Indian Region. This was prepared under the guidance of Ministry of Earth Sciences, MOES, Government of India. And particularly, I would like to draw your attention on this drought and flood, chapter number 6. I have co-authored, and our associates also. So this is an open access book. The link is given here. You can see all the chapters and various chapters, and the book is freely available. Please go through that. I will be describing some of the analysis what we have carried out in this drought and floods, and another again from University of Sikkim, India. We are also writing one revised this chapter on droughts and floods. Before I get into some science, let me also describe this activity, this CORDEX. You may be well aware of this CORDEX South Asia. This is a coordinated regional climate downscaling experiment, CORDEX, and IITM has been initiating or leading for CORDEX South Asia coordination activity. We have conducted several workshops, and this data is shared. So a lot of data on climate historical as well as projections are available, and this data can be seen from this our website, and it can be downloaded. At the same time, we are also IITM, we are proud to be the third one in Asian countries to host this Earth System Grid Federation, where again this data in all the possible formats are available. So you can download the data, whatever the data you require. This is the website we are giving, and if you have any difficulty, you can contact through cccr@outreach@dropmet.res.in. You will get the good support for this. So let me also, before I get into this, let me just briefly tell about this Earth System Model, IITM Earth System Model. IITM Earth System Model is the first one in India initiated, and we are developing a global high resolution 27-kilometer atmospheric version of this Earth System Model. There are these CMIP 6 projections also will be available on ESGF from the this IITM Earth System Model, and eventually we will also share this high resolution model. Let me start with this first this All India Summer Monsoon Rainfall Time Series, which is the famous and it is based on IITM as well as India Meteorological Department data for long-term time series. This is the first, I mean, it is available on IITM website, and it is updated time to time. So the thing is, this is the rainfall anomaly. You can see starting from 1871 onwards till, and it is updated 2020. So you can see that, I mean, different characteristic. Even, I mean, with this slide, with this time series, it has a lot of potential. I mean, lot of information to investigate and to reveal lot of hidden characteristics of this monsoon. So particularly the droughts, I mean, drought we are describing below 10% of the anomaly or percentage of mean average. When the All India Summer Monsoon rainfall is below 10%, we call it a drought. When it is above 10%, it is flood or excess year. So deficit or excess year, whatever you call. Normal, again, zero lies on the normal. And then, you know, and La Nina events are also described, I mean, by these dots. So the one interesting part is, of course, I mean, the very first question is, what is the trend of drought over India? Yes, I certainly agree. There is no significant trend of these droughts over India. But you can see, I mean, in the past, I would like to draw your attention on this. Droughts have been varying. I mean, if you see from 50s, the droughts have increased. That is very true. I mean, post 50, and particularly the consecutive droughts. You can see these consecutive droughts during 1904, 1905, 65, 66, and then this 85, 86, 87. I mean, this was a really long drought period. And recent one, 2014 and 15. We have this paper on 2014 and 15. 15 was again peculiar drought. Actually, drought we have been talking about India, but just I want to give the brief of this peculiarity of this 2000 drought, which had covered a large area of South Asia and Southeast Asia. So this rainfall deficiency during 2015, I mean, throughout the Indo-Malaya region. I mean, this is called the Indo-Malaya, one among 8 great ecozones that cover Earth's land surface, encompassing South and Southeast Asia. And a lot of details are available. Actually, if you are interested, please, you may be able to go through this INCEPT NOAA website, and how this 2015 evolved because of, I mean, there is various factors we have described in our paper, and this east-west asymmetry, again, the large-scale shift of this large-scale circulation, large-scale shift of large-scale circulation that has caused this very widespread drought. So this is just about the glimpses of the drought, what the peculiarity of the drought, but how to analyze the drought. Now the question comes about how to analyze. There have been several attempts. I mean, indices. There are several different indices have been prepared and proposed, and a lot of literature is available. We have listed that literature here, depending on the using the soil moisture, runoff, evaporation, rainfall, temperature, various factors have been done. But if you see among these, I mean, PNP, this is the normal precipitation. Very famous is the Palmer Drought Severity Index, PSD, PDSI, and then standardized precipitation index also, depending on the precipitation, using the precipitation only. But what we have used here in this study is SPEI, Standardized Precipitation Evapotranspiration Index. So here the advantage of this SPEI is it encounters, it considers this impact of warming temperatures, and of course, I mean, through including the effects of temperature via evaporation, evaporative demand. So the thing is, I mean, in the perspective of global warming, how the drought can be defined. So this may be one of the better or one of the more suitable drought index. So we have, I mean, we have taken into account, and then we have, you can see that using this index, we got this, just I want to describe this 1901 to 2015 droughts actually. So you can see here the particularly the decade wise, there have been, I mean, 61 to 90, there have been 8 droughts, and recent one 5 droughts. So this is one thing. I mean, recent 2002 and 2009 droughts, these are also very severe droughts, and how these things are changing. Again, here again all the details are given in the book, but the main thing is how to attribution. Detection is one thing, but the attribution is the main thing what we need to look into. I will come to that again. So using this SPI index, the spatial distribution, actually the spatial characteristics of this drought, how these droughts are for SPI. So what we have done is, during the JJS southwest summer monsoon, and then winter monsoon, northeast summer monsoon, and then the northeast monsoon, and then the annual one. So you can see very clearly the Gangetic Plain, northeast central India, northeast central and northeast central India region. It is a prominent, the droughts are the drought characteristic or drought indication. There is a lot of, I mean, the drought events are increasing over these regions, particularly the frequency. If you see the annual frequency of annual droughts also increasing over the same region. So these are the vulnerable regions. I mean, Gangetic Plains, central north and east central India, northeast India, and parts of this southern peninsula region also. So these are the spatial distribution of this this drought characteristics intensity. And another thing is here, interestingly, as I said, I mean, if you see the SPEI index, I mean, year to year, just I have shown this JJS for summer, winter monsoon, this northeast monsoon, and then annual also, on annual scale. So this is based on monthly data, and you can see there is no clear-cut trend in that. However, if you see this is the right panel is for the same, I mean, summer, northeast monsoon, and annual for the percentage area affected by drought. So where we have taken SPI is less than 1. So grid point, each grid, this SPI is computed, and then we have seen that where we have counted those, and then percentage of drought area we have evaluated. You can see very clearly very significant trend is there. So the percentage of area affected by drought is increasing significantly post 50s. That significant increase is seen during summer monsoon, northeast, and annual also. Now the thing is, I mean, just very briefly, I want to just talk about this mechanism of drought. Of course, there are three components, major components. One thing is the boundary condition, how the boundary condition is induces the droughts over India. Another one is the interactive dynamics. Internal dynamics plays an important role. This has been very well discussed, and a lot of studies are there. And then another issue is the other regions, I mean, other causes, particularly the anthropogenic. Here, the thing is, on this recent paper also, and many studies have described this through precipitation variability, temperature variability, but drought variability, are very few studies are there, particularly the anthropogenic, the influence of anthropogenic. Of course, I mean, surface boundary condition, as you say, land surface processes, SST, boundary forcing, ENSO, IOD, these are the major climate factors which influences the droughts, the evolution of droughts over India, and Eurasian snow cover. And interactive dynamics, if you see, starting from low frequency, intraseasonal oscillations, 30 to 60 day mode, northward as well as eastward moving modes. So these are the things. And then another time scale is the synoptic scale, less than a week. So here also the influence of this southern hemispheric mid-latitude influence, Pacific and West Indian Ocean, Indian and West Pacific Ocean warming, the SST particularly here, how this plays an important role in evolving the synoptic scale systems over Arabian Sea, Bay of Bengal, as well as the West Pacific Ocean. And northern hemispheric mid-latitude, again this interaction, the mid-latitude intertropical, tropical and extratropical interactions. So some of the droughts, again the characteristics of the droughts, again little about the droughts over India. The central India, this 87, if you see year by year, there have been a lot of studies. Krishnamurthy, Professor late, well-renowned Professor Krishnamurthy has studied this, and we have followed this. 87 drought. It has been well studied, and particularly, this was attributed mostly to warmer equatorial Indian Ocean and Pacific ENSO-related, IoT-related SSTs. While this 2000 drought, again the northwest and central India, again this over this region, 87 was most prominent over the central and north India. 2000 was northwest. 2000 drought was mostly confined to northwest and central India. We have studied this in our Journal of Climate paper, and we have again this equatorial Indian Ocean SST and southern tropical Indian Ocean SST we have attributed to that, how the asymmetry over the convective asymmetry over the ocean and land, it tend to induce this sinking, and then tend to induce the drought. The same way, this 2002 northwest part of this India, this drought, when the northwest was under this drought conditions. So we have, there are several papers. We have studied this again, connecting it with the north central Pacific, how northwest and north central Pacific convection has induced the suppress the convective activity over this Indian subcontinent, and tend to induce the drought conditions over northwest and part of India. Kripalani et al. 2004.
Dr. Majumdar,
yes, sir.
If you can quickly summarize, because
okay, sir. Okay, so this is the again the projections based on our Cordex. Actually, you can see again the SPI index here. If you see just the index, the trends or the spread is large. So here we have the less confidence in this describing the droughts. But if you see the area, difference in percentage area, so difference with respect to historical period. So with the base period, if you see the area, again the area, it is very consistent that the area is increasing. So that is in the historical period as well as the future projection also. And the same way you can see over this spatial distribution also. particularly that is the frequency changes. You can see very clearly during the this RCP 4.5 and RCP 8.5 projections. So both indicate the same enhancement of the intensity also. Very clear. I mean, very quickly, as I have been given warning, I'll just describe this. The knowledge gaps. What are the knowledge gaps? I mean, having seen these things. So I mean, we need to have this soil moisture. These observations, very large network of observations, and to have the understanding of complex, multi-scale spatial and interaction taking place in climate system. Another thing is an attribution of anthropogenically induced climate change. This is also a very important thing we need to really look into. And of course, I mean, this model uncertainties also we need to count. And then of course, this is again another area is assessing the impact of increasing urbanization. And for this, we have made an attempt. We have this field scale, large scale cosmos, this observations we are taking here. We have published one paper and another one is in the pipeline. So this is the one way, I mean, one better way to have the network of cosmos soil moisture observation system, which gives you the field scale or the large scale in situ observation. Again, here the main thing is the highlight of this study is the increase in drought severity. Yes, that is very much there. We have the high confidence in that, and this has been attributed. I mean, the whole main thing is this has been observed through decline of rainfall actually, and projection also indicate increase in frequency very clearly. Very briefly, I will describe few studies where the attribution has been taken place. Dr. Krishnan and our study also describes this, how this taking difference between historical and natural. So if once you take the difference, you see that how this, what is the this attribution very clearly, the weakening of lower tropospheric circulation. So this has been, I mean, this again, as you see, I mean, the difference.
May I request you to conclude?
Yeah. Yes, sir. So this is also, I mean, the same way. This historical this GHG experiment, you can see the enhancement of this extreme events actually. And of course, I mean, this I will not get into, but these are the three things, sir. Three studies, very recent study I have gone through, and this is a very recent study where they show this the difference between CMIP 6 and CMIP 5, where the decrease of dryness and increase of agreement and disagreement. So this is, but still the attribution part remains very open, and we need to look into more attribution studies. Thank you, sir.
Thank you very much for your wonderful presentation, Dr. Milind. I think, unfortunately, due to limitation of time, we cannot enjoy the questions. Even then, if any of you have only one question, I can welcome. I can adjust the time later on among others presentations time. So if any of you have questions, just only one, I can welcome one question. If not, then yes, please.
If you allow me, sir, I can ask one question.
Yes, sure.
I mean, regarding the concept of drought, I find that it is in between meteorological and agricultural drought. It is not following any particular stream of drought. So in that context, how the role of irrigation is taken into account in this drought consideration? Is there any role of irrigation, artificial irrigation?
Yes, sir. Yes, sir. I think, I mean, this is related to agriculture practices, and this irrigation is so. I think, I mean, that there it is more hydrological, or we can say that more we need to have the observation, soil moisture observations for that, sir. Merely the rainfall, precipitation. Yes, you are absolutely right. The atmospheric, it is not the atmospheric meteorological drought, but it is more of kind of hydrometeorological. We need to have more exposure of those observations, and then we can talk about that. Thank you.
Thank you, and I'd like to invite next speaker. Next speaker is Sakhaut Hussain. He's talking about rainfall runoff modeling for flood flow prediction using HMS in the northern part of Meghna Basin. Welcome, Shakhawat. You can start now, and your time is 15 minutes only. And 5 minutes, let's allow us to enjoy the questions for 5 minutes. Please start, Shakhawat. I'm with you in your paper.
Yes, thank you, sir. And good afternoon, all. Uh, Welcome to my presentation. And I'm Sakat Hussain, an MSc student from Department of Meteorology, University of Dhaka. And my research title is Rainfall Runoff Modeling for Flood Flow Prediction using HMS in the northern part of Meghna Basin. So this is the outline of my presentation. So first, I will try to briefly focus on the introduction and objective. Then I will try to explain the study area and its impact and conceptualization for hydrometeorological studies. Then in data and methods, I will try to explain what types of data I have used and methodology I have followed in my study. And then I will try to represent my results and analysis from the research. And finally, I will conclude this. So we all know Bangladesh is a deltaic country and located in the just head of the largest Ganges Brahmaputra Meghna Basin system. And the country is the physiography, almost 80% physiography is floodplain. As a result, huge rivers, including tributaries and distributaries, are flowing through this country. And in almost every monsoon season, the country passes nearly 10 lakhs cubic water within this country. And on the other hand, the country is lying just downstream of the GBM basin system, and the upstream rainfall mostly causes these floodings. So rainfall runoff modeling and such sort of research has a great importance in hydrometeorological studies for this country and its economy and livelihoods. So my objective is to develop a rainfall runoff relationship for effective monsoon flood flow prediction in the northern part of Meghna Basin concerning Meghalaya and its associated Bangladesh part. So in this slide, I have presented a map of my study area. So you can see the inset map where the location of my study area is depicting related to Bangladesh. So the study area is located in the northeastern part of the country, and it's the whole area of my study area is nearly 7,000 square kilometer, and it's occupying both Indian and Bangladesh territory. So the 60% of my study area lies in the Indian territory concerning the Meghalayan part, and 40% lies in Bangladesh. And in Bangladesh part, the study area occupies two districts. So 60% of Sylhet district is occupied by this study area, and Sunamganj district about 17%. And regarding the land use and elevation and slope, all of the maps I have produced, and I will show it in the following slides. So here I have presented geographical aspects, because in hydrometeorological studies, these aspects have a great importance to conceptualize, to model, and calibration and validation. So first, the two maps in the upper panel, the elevation and slope. These maps are produced in ArcGIS 10.5, and these are maps produced from SRTM 30-meter DEM data. So in the upper left panel, the elevation is represented, where the elevation within the study area ranges from 10 meter to approximately 3,000 meter. And in the downmost part, you can see the nearly greenish color is indicating the in Bangladesh part is almost flat, but in the Indian part it's hilly, and it ranges up to the 3,000 meter. And in the upper right panel, you can see the slope. So in Bangladesh part, as it's almost flattened, on the other hand, the northern part is hilly. As a result, the steep gradients are found in that region, and it reaches nearly 90-degree almost. And in the down panel, you can see the land use and soil types. So the land use map is produced from the globe cover data, and most of the areas, nearly 60% of this area is covered by the forest area and other shrubs and croplands, and very few portion is found the barren lands and other water bodies. And on the other hand, the soil types map is produced from the FAO soil groups data. So two types of major soil groups are found there. One is acrisols and another one is glacials. So acrisols is having characteristics of well draining capacity. On the other hand, the glacials are poor draining capacity. So in the Indian part, I found most soils are dominated by the acrisols, and glacials are mostly dominating in the Bangladesh part. So these are the geographical aspects. Then I have tried to portray some rainfall climatology based on Aphrodite 1901 version climatological data, daily data. So here, 4 monsoonal months climatological data I have presented here. So we can see the intense rainfall in July, and almost in these 4 months, June, July, and August, you can see the northwestern part is dark green, dark blue. That is indicating the rainfall is more than 55 millimeter per day. This is due to because we all know the highest rainfall zone like Cherrapunji and Mausinram, and both are located in this region, and this lies within my study area. So it has a great importance in my study. So in this slide, I have prepared a flowchart of my data and methodology. So I have tried to explain it in brief. So first off, in data collection, I have collected meteorological data, that is Aphrodite rainfall data daily, and that was 0.25 degree resolution. And for hydrological data, I have collected water level data in daily scale from Bangladesh Water Development Board. And for catchment delineation, I have used SRTM 30 meter DM data from USGS. And then for conceptualization of hydrometeorological aspects, I have used globe cover land use data and FO sol groups data. So after collecting all of this data, I have done some pre-processing. So first comes the meteorological data pre-processing here. First, I have used Python coding to extract the grid point rainfall values. And then I have used the Thiessen polygon method in ArcGIS to calculate the weighted mean precipitation for each sub-basin. And for hydrological data, I have collected the daily water level data, then a tool named HQ rating tool that is developed by Dr. Engineer Dilip Kumar from Department of Meteorology and Hydrology and Meteorology from Nepal. So using this tool, I have used the rating curve method to generate the daily discharge data. And then from SRTM, then in HGeo HMS and ArcHydro tools, I have used the flow reaction, flow accumulation, dam recondition, and other tools to formulate the basin and to collect, delineate the basin area for my study. So after doing some all this pre-processing, I have set up my hydrological model in HEC HMS. So there are some components. So the major components are the basin model, where the model is portrayed manually in HEC HMS tools. Then in meteorological model, there are several methods. So in my study, I have used the hydrograph method because it's user defined. So I have a freedom to work with this. Then the control specifications component is actually defines the start and ending time of the simulation, and it also defines the time step. So in my study for calibration, I have used 2010, 1st January 2010 as my starting time, and ending time 31st December 2013. And for validation, it was 1st of January 2014 to 31st December 2015. That means 2 years. And my time step was daily. And the time series data, this component is actually the input of hydrometeorological model. So here I have started my processed meteorological and hydrological data. That means the rainfall and discharge data. So after completing all of these things, I went for the model calibration process, and here I have followed the semi-automation process. So semi-automation means there is a built-in option that is automatically iterates several times and try to matches the simulated data to the observed data. And I have tried this several times, and sometimes I have also done some manual tuning as my conception was built based on the geographical and climatic aspects. So after the calibration, I check the results, and if the results are good to go, then I follow the forwarding method, then I go for the validation. And if the result is not good, then I just return back to model calibration process and doing some several other iterations and try to satisfy the result quite well. Then after validation, I have also checked the result. If the result is good, then the result is ready for analysis, and I have done this. Otherwise, I just return to the model calibration process and repeated the results until it reaches to a good one. So after this, this is the model I have portrayed manually in HEC HMS 4.4. So here you can see these are the sub basins that is indicating the small watersheds or sub watershed sheds, and then this is indicating by the SB. So herein I have found 27 sub basins in my study area. Then the reaches are indicating by the blue straight lines. So reaches are actually the rivers in reality. So I have found 19 reaches are modeled here. Then by J, junctions are indicating. So 19 junctions, that is actually the confluences of rivers. And in the red circle areas is actually the observational data points. So the right one is here is Sarigat. So the Bangladesh Water Development Board has an observation station here, and the another one is left, Sunamganj, that is the outlet of my study area, and I have found the observational data here. So in this point, I have simulated my model. Okay, here is the parameters. So these parameters I have calibrated in my study. So there are some methods. First comes the interception launch. So when rainfall occurs, first it is intercepted by the canopy of the vegetation, then it's intercepted first by the surface. Then it goes underwater, and sometimes it, and otherwise it goes to runoff. So interception loss has a great importance here, because in my study area, almost 50% of the study area is dominated by the forest. So vegetation has a great importance. Then about the loss, I have used the soil moisture accounting method, because soil has a great impact and importance in hydrometeorological studies. So the base flow and the underground flow is a great importance. And so to portray this, I have used the SMA method. And in transformation method, I have used the Clark unit hydrograph, because it's actually the user-defined hydrograph method. No need to analyze based on the past observation. So using that method, I have calibrated the time of concentration and stress coefficient parameters. And then base flow, I have used the linear reservoir, and routing, I have used the masking method based on the previous studies. So then using the calibration process, these are the output of my calibration. So I have presented here the two hydrographs. One is for Sarikat in the right upper panel, and the another one is for Sunamganj in the left upper panel. So in these graphs, actually I have presented from 2010 to 2013, and the green line graphs are indicating the simulated runoff, and the black ones are indicating the observed data. So in Sunamganj, we can see that the pattern is more or less similar, and it's matches to the observed data very frequently. But in Sarikat station, we can see that the green lines are matching to the observed value, but in dry periods, it's deviating. There is a reason behind this, because the observed station available in my study area, there is a data missing for dry periods. Almost in each year, the data is missing from 1st of November to March. As a result, the model cannot simulate it properly. But for monsoon region, as there is observed data, the model can simulate it quite well. Sometimes it's underestimating, but the pattern is more or less similar to the observed data. So according to Moriarty performance scale, I have evaluated these simulations. So I have used these indicators like NAC, R square, P bias, and RMSE and RSR. So these values are according to Moriarty scale 2007. These all are satisfactory. So then I have gone for model validation process, and here you can see the observed and simulated hydrographs. So in Sunamganj, the pattern is very similar to the observed data, but there is a problem in 2014, because the data was missing from 5th of July. As we see in the climatological rainfall, the highest rainfall occurs in the month of July. So it's actually interrupting the results. That's why I have splitted the results in the table for 2014 and 15 first, then only for 2015. So you can see the all results are improving quite well. Like for Sarikat, the NAC value increased 0.31 to 0.5, and for Sunamganj it was 0.77, then it increases 0.83. For while I just considered 2015 based on the available observed data, it's quite well matching.
Mr. Sakhawat, can you please summarize in 2 minutes?
Yes, sir. Thank you, sir. And so this is the table after the calibration. So here I have shown 4 sub-basins that is located upstream of Sarigat stations. So these are all the values, and based on the examination, these are matches to the reality. And this is the continuation of the previous table, and other parameters are also shown in here. Then this is the hydrograph. So when KHMS model is simulation is run, then it produces hydrographs for each sub-basin and its junctions. So these hydrographs are for the sub-basin 9, that is actually located in the upstream of Sarigat and in the Meghalaya and hilly region. So examining these 4 years hydrographs, we can see the orange graphs are actually indicating the discharge, and the bar graphs by green bar graphs are indicating the rainfall. So here I found the lag time is within 24 hours. So it's usual in the reality, because in the slopey and steep gradient regions, it's usual the water is flowing quicker. So the 24 hours lag time is matches to the reality. So and the model simulates is quite well. And for 2000, for subbasin 12, that is located in Sarigwain region within the Bangladesh, and it's downstream relative to this. And here I have found, while I examining this peak discharges, so the lag time is found 48 hours to 72 hours. So it's usual when it flattens, then the water is coming slower than the steep region. So this is the results. And finally, in conclusion, I can say, yeah, my model is the pattern is similar to the observed data in my HKGMS model calibration and validation processes. The statistical indicators are showing good results. So, and the HKGMS model can successfully estimate flood flow for Sarigat as well as for Sunamganj stations. But for Sunamganj, as it is located in downstream, so it simulates quite well, better than the Sarigat station, because it's downstream part. So it's very good. And then in my study, I have also used the soil moisture accounting method and the plug-in hydrograph method, and the model can estimate these parameters quite well. So this is all from my study. Thank you all. And I would ask you if you have any suggestions and queries, please. Thank you all.
Okay, thank you. Wonderful. Sakhawat. Well done. And I'd like to request all the participants if there are some questions.
Yeah, I'm Mohammad Sadat Hussain from
Yes.
IWM. I have some questions. First of all, thanks, Sakwat, your nice presentation.
I really appreciate if we can see you.
Okay.
Yeah. Yes, please.
Sakwat, your calibration point, that means the final outlet is Sunamganj. That means it is on the Surma River, yeah?
Yeah, Surma River.
Yeah, but Surma River, actually, Borak River bifurcated at Amul Sid in two rivers. One is Surma and another one is Kusiara.
Yeah.
So Surma River, 40% flow carry from the Borak, and the rest of the 60% goes to the Kusiara. But in your model, you do not consider the 40% inflow from the Surma River. So I have doubt how you can calibrate at Surma point, and Sunamganj point without considering the Borak contribution. That means 40%. In the monsoon period, there are a lot of water come from the Borak basins, but you do not, you didn't consider that part in your model. So it is a huge drawbacks, I think. And another thing is the Sunamganj point, water board didn't frequently take the discharge data. So I think I have also a little bit doubt on their major data, because you use the rating curve discharge data, yeah. So there is a problem also here. So I think there will be a lot of questions arise in future if you do not consider the Borak flow in your model, yeah.
Yeah, in my study, I can show you here, like in Sarigat, there is no contribution from the Borak River. So it's
No.
well,
at Amulsid point.
Yeah, I know, but in the downstream, the other basins are still needs to be calibration, incorporating the inflow, and it's my future work plan. So I will do that in future, and I think when I incorporate this data, it will the accuracy will be enhanced much more.
Okay, thank you. If there is one more, Mondal, Dr. Mondal, is there time for one more question? Or is already we are out of time?
Yeah, we still have 2 minutes.
Okay,
so we
then
can take one more question.
one more. Yeah. If not, then we go for the next. Toma Rani Shah. She's from C or he, I don't know. Monitoring and assessing drought in South Asia. She's from Department of Computational Hydrosystem in Germany. Please welcome. Toma, you can start now. Are you here?
Yes, I'm here. I'm just
Yes,
let me share my
please.
screen.
Yeah. And one of the things I like to mention, all of the participants, including presentators, we would like to have a group photograph at the end of this session. So stay connected.
Give me a moment. I'm just. Can you see my screen now? Hello.
Yeah, we can see your screen.
Yeah, it's very nice. We can see.
So welcome everybody to my presentation on monitoring and assessing drought in South Asia. So this research has been conducted with the support from Alexander von Humboldt Foundation, Germany. And I was hosted by the Helmholtz Center for Environmental Research in Germany. And today I will introduce you with a drought monitoring tool which I developed during my research. And also I will discuss a little bit about the role of precipitation uncertainty in monitoring and assessing the drought in South Asia. So when we talk about the drought in South Asia, we need to consider that like South Asian region have been among the perennially drought-prone regions of the world, and South Asian countries like India, Pakistan, Sri Lanka have reported droughts almost in one drought in every 3 years, while the other countries like Bangladesh and Nepal also suffer from frequent droughts. So, and drought also has impact on the agriculture, water supply, ecosystem, and the economy of this region. In my study, I have considered 7 South Asian countries, which are Afghanistan, Bangladesh, Bhutan, India, Nepal, Pakistan, and Sri Lanka, and also covered the major river basins, Ganges, the Indus, the Brahmaputra, and the Meghna rivers. And so, as from the previous statistics, we see that almost all the South Asian countries have experienced the impact of droughts in many years. For example, in Bangladesh, a big drought in 1982 caused a loss of about 53,000 tons of rice, and also in India, frequent drought also happens. For example, in 1978, 1987 drought, 2002 drought, 2003, and in 2010 drought affected more than 40% of the country. So when we talk about mitigating the impact of drought, we need to focus on drought. And in these sessions, I will especially talk about the agricultural drought. And I have studied the agricultural drought in terms of the soil moisture. So we want to introduce this tool which can help to mitigate the drought by providing the soil moisture condition in near real time in high resolution, and also dissemination of drought information is important. So we try to look into that. So when we talk about the drought monitoring current system in South Asia, we can see that in South Asia already a lot of researches have been done in monitoring the meteorological drought as well as the hydrological drought. For example, the South Asia drought monitoring system. So far, I know the first drought monitoring system, which was developed in 2014 for South Asia, and this drought monitoring system provides the weekly map of drought, and this one is mostly based on the remote sensing technology and the satellite images. And this tool provides drought information at 500 meters spatial resolution. And the next tool is the high resolution South Asia drought monitor. And this tool was developed by Indian Institute of Technology, Gandhinagar. This tool provides weekly and monthly drought information for meteorological as well as hydrological drought. And this tool was developed by using TRIPS precipitation dataset and updated in a regular basis, and has a lag time of 1.5 months. And the next tool is the regional drought monitoring and outlook. This tool was developed by EC Mode, and it's currently running. This tool provides mostly the data of soil moisture, precipitation, air temperature, and evapotranspiration, mostly based on the land data assimilation data sets from NASA. And So I actually tried to develop a new drought monitoring tool, especially for agriculture, using a hydrometeorological model. This tool, I hope, can overcome the challenges of getting drought information at near real time. And currently, this tool has the shortest lag time, which is 5 days. Besides, this tool is running at high resolution, which is 0.25 degree. Moreover, we want to provide an open and interactive platform for everyone. And for this journey, I basically considered three basic steps. First, we implemented the meteorological hydrological model, the MHM model, to reconstruct this daily and monthly soil moisture using historical meteorological forcing, morphological variables, and land cover data. Secondly, the soil moisture index was estimated by estimating the quantile of reconstructed soil moisture. And then the generated soil moisture indexes were divided into five categories based on their severity. And thirdly, the soil moisture indexes or the soil moisture information through maps and statistics are updated to the South Asia Drought Monitor on a regular basis. Daily and monthly informations are available in that website. So the input data we have used includes a number of morphological information and meteorological information, as I said. So the morphological informations are the terrain elevation, soil type, geology, land cover, and leaf area index. And I have provided the link and the processed resolution for each data set here. And we also use the precipitation and temperature forcing from the era 5 dataset at 0.25 degree for the meteorological input. And so to reconstruct the soil moisture using mesoskal hydrological model. And I would like to say a little bit about the model. So this model was actually developed by the Hemos Center for Environmental Research, and this is a grid-based hydrologic model that considers its grid cell as a hydrological unit, and it accounts for the subgrid variability of the physiographic characteristics. And also this model, by using the morphological and meteorological information, calculates the number of hydrological data, mostly the information about the data of canopy, interception, snow accumulation, soil moisture dynamic, infiltration, surface runoff, evapotranspiration, and groundwater storage, base flow, etc. And after and this model actually reconstructs the soil moisture at 6 different horizontal layer. As we know, in South Asia, mostly the soil moistures are available up to 30 centimeter mostly, but in Himalayan region, the organic content can be found up to 300 centimeters. So we try to construct this scenario in 6 different horizontal layer up to 300 centimeter, and then the and from that calculation, the root zone soil moisture were estimated for this study. And after calculating this soil moisture, we tried to estimate the soil moisture index. And this soil moisture index represents the soil moisture deficit compared to the seasonal climatology of that particular area. And this index is calculated by estimating the quantile of soil moisture for a particular month and for a particular grid cell with respect to its cumulative distribution function. And to calculate this index, we use the standard methodology developed by Samaniago et al. In 2013. And this is the standardized procedure we also use for a kind of similar procedure we do for SPI or SPEI or any other standardized index. And this soil moisture value is actually calculated in a range of 0 to 1. And here a value if it's close to 0, that indicates areas with higher water deficit, and a value close to 1 represents wet soil moisture conditions. So we use the standard classification system developed by Soboda et al. In 2002, and this classification system is widely used and was introduced through the US Drought Monitor. And this classification system divides the soil moisture index into 5 categories based on the severity. So this scale is given here. So abnormally dry to exceptional drought condition. And the exceptional drought condition means the most severe drought condition, which has a threshold limit less than 0.02. And besides, although we are using ERA 5 to run the South Asia Drought Monitor, but during the study we ran the model with 3 different precipitation data sets. Mostly we wanted to see the impact of precipitation uncertainty on the estimation of agricultural drought over South Asia. So for this comparison, we used ERA 5 as well as CHIEF's version 2 and PGF, the Princeton Forcing Datasets version 3. And during this analysis, we actually observed that the soil moisture index output obtained from all 3 data sets show almost similar dynamics, but although there are some variations. For example, in figure A, we can see that the dry period from 1985 to 1988 and the dry period from 2002 2002, all 3 forcings were able to capture this true drought condition. On the other hand, the during the wet period, for example, in 1992 to 1998, and during the period of 2007 to 2013, this all 3 forcings, they show some variations in their output. And compared to the ERA 5 and PGA version 3 datasets, CHIEF's version 2 depicts less temporal variability in its distribution. And here we can see we also tried to calculate the identify the major droughts from 1982 to 2016. During this period, which major droughts have happened in South Asia based on all 3 data sets. And the major drought characteristics we identified are the areal extent of drought, which is the area and given in percentage here, and also the mean duration of drought given in months. And also we tried to look into the total magnitude, which is expressed in months time the percentage of total surface domain. And this analysis was done by using a clustering algorithm. And for this the drought was like we considered only those droughts which was below SMI 0. SMI value was 0.2. Only those droughts were considered as, only those dry periods were considered as drought for this clustering analysis. Besides, here we can see that the major drought events identified by all 3 precipitation datasets are similar, but in their ranking there are some differences due to the effect of the precipitation forcing. And for example, the 2 driest period identified by all 3 datasets are the periods during 1999 to 2003. So this big circle with PGF version 3 and these 2 circle with the CHIEFs and this circle with ERA 5. So these are dissimilar droughts, but based on the precipitation data sets, the mean area and the duration differs. That's why based on which data sets we are using, the severity and the classification of drought might be different, but all these 3 data sets were able to identify the big droughts in South Asia. And in next 3 slides, I have a little bit of description of my tool.
If you can summarize in 2-3 minutes, that will be fine.
Yeah. So I will just go through share my tool in this screen, and then I think I can go to the conclusion.
You still have 2-3 minutes, so you can continue.
Yeah. So I have shared my screen. Can you see this this website?
Yeah, we can see it.
Yeah. So these websites provides the soil moisture conditions. So the soil moisture maps from 1982 to near real time. So it has a lag time of 5 days. Now the latest map is updated on 6 December. So anyone who is interested to see the soil moisture condition during this time period can easily display and animate the soil moisture map from this tool, and they can select the years. For example, if they select the year 2001, for example, and they can display the map for those particular mountains. And besides, this tool also provides the time series of the droughts during this time period. I mean, from 1982 to 2016. So the time series is also updated every day, and they can easily get the information of current drought which is going on, and the historical drought, and they can user can also make comparison of the severity and what measures needs to be taken. Besides, this tool also provides option for downloading the data. So the daily soil moisture maps and the monthly soil moisture maps, as well as monthly data, can be downloaded from this website. And this is now open and available for everyone. So feel free to visit this website. I encourage everyone to go to this website and provide us some feedback to improve this tool further. And so these are some basic features which this tool have, which I have already explained. So considering the impact of drought in South Asia, I would like to say that this tool has potential to contribute towards taking adaptation measures for drought, and also help the policymakers to take some measures for mitigating the drought situation. So yeah, thank you everyone for joining this talk. Yeah, thank you. If you have any questions,
very
please.
much for your wonderful presentation. If there are any questions.
I just
Yes.
know, I mean, regarding the temporal resolution of the analysis. What is the temporal resolution of the analysis? When we say drought, I mean, the time domain, time dimension, that is not very clear to me, or I have missed it, maybe. It is?
So it was from 1982 to near real time. So 6, I mean, you can say like 5 days before today.
But what about, I mean, when we say drought, I mean, what is the scale of analysis? Say hourly.
So the drought condition, I mean, so based on the historical, historical means the time period we considered, for example, if we consider the drought of today, so it takes into consideration the drought from 1982 to 2000. I mean, the drought of yesterday, and then it reconstruct the cumulative function, and then it measures the index.
So scale is daily? It comes as daily, or?
Yeah, it daily and monthly. Yeah,
daily and
both
monthly.
daily and monthly.
Thank you.
Okay, then shall we go for the next, or we wait for one question? I think we have 1 minute.
Yeah, we still have 1 minute.
My watch, although we are 15 minutes different. India, Nepal, and Bangladesh. So if not, then why not we go to the next? Saria, please prepare your slides. Next presenter is Saria Marine. She is from University of Dhaka, Department of Meteorology. She worked on simulation of radiation fog. Saria, now you have to handle. Sharia, are you here? I think Sharia is not here. She should be here, I think. Do you know Sakawat?
There,
Sharia is here?
Her speaker, speaker is to be on. Put your speaker on.
Sharia?
Your mic is not on.
He's saying, sir, but maybe.
Mic is not on.
You need to increase the volume, maybe.
No, mic is not on at all.
My microphone is on, we can see.
No,
Sir,
your
her
is okay.
microphone
Sharia,
is not on.
if Sharia is not here, then we go for the next one.
No, she's there, sir. She's
Okay,
there. She's very
Sharia,
much
then
there. And we are able to
start.
see her.
Yeah,
But-
we can come back later, maybe.
No, Sharia, are you here? Are you hearing me? Yes, please, Sharia, please. Otherwise, I will switch to the next. Okay, Dr. Mondalo, what do you think that, shall we go first to the next?
Yeah, I
Mozilla?
think so. Yeah. So by this time, she can look at her audio system.
Then Mozilla, please prepare. Are you here? Monzila Jahan, University of Dhaka. Oh, we are hearing something. It may be echo or Mozilla is talking. Both are absent. What's wrong?
You see Sadia, we can see Sadia, but we cannot hear her voice.
Can you see my presentation, sir?
Yeah. We can see you. Yeah. Okay. You are Monzila Jahan, right?
Yes, sir.
Yes, please go
Thank
ahead.
you, sir.
You are talking about monsoon flood forecasting,
sir.
right?
Yes, sir. Yes, sir.
Okay, please go ahead.
Sir, Monzila Jahan.
Yeah.
Myself, Monzila Jahan, MEC student, Department of University of Dhaka, Bangladesh.
One of the
First
thing
of all-
Monzila, one of the thing I
Yes,
forget
sir.
to mention that even Sakawat said that you are a MSc student,
Yes,
but
sir.
I
Yes,
think
sir.
that you all are already graduated. You are not a MSc student. You already.
Sir, sorry for the
Sir,
interruption. Our result has not been published yet, sir. That's why we are saying.
No. Okay, please, Monzila, go ahead.
Thank you, sir. First of all, I would like to thank my chair and co-chair and the co-chairperson of Department of Meteorology, University of Dhaka, Bangladesh, to give me the opportunity to present topic. My presentation topic is monsoon flood forecasting of Dhara Basin over Bangladesh. So welcome to my presentation. Here is the outline of my presentation. First of all, I would like to explain the introduction, the object study area, methodology, result and discussion, and last of all, the
I
conclusion.
think your screen is not shared.
Introduction. Sorry, sir.
I don't see your screen. So you can go to screen share if you have not already done it. Yeah, now it is coming.
So can you see it?
It says that it started, but still not coming. Yeah, it has now arrived. So you can go ahead now.
Here is the outline of my presentation. Introduction. Bangladesh is located in the tropical monsoon region, and rainfall plays a crucial part for flood in this country. And it is known that the 60% of land in Bangladesh is located on the world's most important delta, comprising the world's most unstable river named Ganges, Brahmaputra, and Meghna, and which occurred annually flood during the every monsoon period in Bangladesh. And the study will incorporate the developed forecast rainfall with the hydrological model HMS. These models are used for a flood forecast for an flood event. Here is my research objective. assess the effectiveness of using WRF predicted rainfall for forecasting, and to increase the forecasting lead time with reliable accuracy of WRF model. Here is the study area of my study. Study area is Kurigram district, which is located beside the river named Dharla. So the effect of Dharla basin for causing flood in Kurigram district were analyzed on this study. As Dharla river basin is a small part of Brahmaputra basin, and due to heavy rainfall and upstream water and the steep slope cause flood every year in this region, and as well as in this year almost 5 times flood hit this region. And for this vulnerability I selected this region for my study for flood forecasting. Meteorology, data collection and procedure. 1 degree by 1 degree grid resolution data is used for rainfall prediction, which is used for the WRF model run, and 30-meter dam is used for basin delineation. And the other data were collected from Bangladesh Meteorological Department and Bangladesh Water Development Board, as well as two heavy rainfall event was also selected for this study and released in 2009. That is more.
I cannot hear. I do not know about others.
Yes, sir.
I think she got disconnected.
Yeah, she got disconnected. Yes.
She's not connected now.
Can you hear me, sir?
Yeah, now he's again okay.
Yeah.
So I think we should pray for the COVID. As there is no COVID, we can be in the same hall.
Yeah. A lot of interaction happens in person.
Sir, can you share my present? Can you see my presentation, sir?
No, please.
Not shared now.
Please share your screen.
You can share again.
Sir, some technical problem actually.
What you can do, you can, unshare and then again share. You can switch off sharing, then start
Okay, sir.
again.
Okay, sir.
Yeah. This is the technology problem you see. And we are dependent so much on technology, we cannot.
We are basically internet is not stable. I think I know that students using some kind of internet that is not that fast.
Hello, sir.
Yeah.
It is not still shared at our end.
Yeah, please. It's not, screen is not shared. Yeah, it's okay.
Now it is coming. Yeah, it is now shared.
Please go ahead.
Can you see my presentation, sir?
Yes, we can see your screen, so you can continue.
Yes, sir. Here is the model WRF model configuration, and the domain configured with 9 km resolution. And some important parameters are also included here, like microphysics scheme and cumulative schemes, which plays an important role for rainfall prediction. After the selection of WRF scheme and the WRF model run, the output of WRF predicted rainfall is used for the HMS model simulation. But before HMS model simulation, basin delineation and some meteorological parameters are prepared for HMS model, and then the flood forecast is given by HMS produced discharge data. Result and discussion. 5 microphysical parameterization scheme and 2 cumulus scheme have been selected for evaluating the forecast of intensive rainfall event over the north region of Bangladesh. Here we can see the list of name of microphysics and cumulus scheme. I selected mainly 5 microphysics scheme, which are Kessler scheme, lead all scheme, WSM3, WSM6, and NSSL2 scheme, which is combined with multi-scale Canfries scheme and Bates-Miller scheme. And the options, model options is also provided in the bracket in this table. Here we can see the performance of the scheme. Here we can see the performance of the scheme 13th to 19th July 2019. 7 days run was conducted for this scheme test. And here we can see that the combination of NSSL2 scheme with the multi-scale cane freeze scheme have less error than the other schemes. So that's why I select this scheme in my study for predicting rainfall. And this graph represents 7 days precipitation of the selected area, and which is average rainfall is collected from BMD for 13th to 19th July 2019. And we can see that which is nearly matched with NSSL2 with the multi-cane cane freeze scheme. This which gives the nearly result with the observed compared with the observed data. And most of the time, the model underestimates the observed value. Here is a comparison between the observed selected model simulated rainfall data at Kurigram station. In the previous slide, we can see that different simulations have been conducted for using this scheme. According to the figure, it is clearly shown that the selected study area have faced heavy rainfall on 15 July 2019, and the less rainfall occurred at 17 July 2019, which is nearly same as the observed. So that's why I select this scheme for predicting rainfall. In this study, hydrological model HKMS is also used and for calibration and validation to a specific time period of flood is used here. The input parameters of this HKMS model for single subbasin prepared by some meteorological data. Here we can see that the peak discharge was 132.7 meter cube per second, and my basin area is a single sub-basin area, and this area is 360 meter square, and the date of peak discharge was 13 July 2016. Here is a observer simulated discharge outlet of the Dhara basin. The simulated total flow of 10 days were compared to the observed ones, and the scatter value of discharge testing the accuracy of the flow. The model of the most of the time the model underestimate the discharge value, but we can see that the trend is almost same for model and simulated discharge, and this is the result of the calibration period. For the validation period, I used 20 days run of WWF predicted rainfall, and which is used in HKMS model as a precipitation data. There is we can see that the peak discharge is 15th July. At the next slide, we can see the simulated and observed discharge for the validation period. And some statistical analysis defines the ability of forecasting from the model output. And the I think the model performance may varies on the duration of the event. Here you can see that the coefficient of R square is 0.78%, and also the peak time of discharge is also same as the model output compared to the observed. At the previous part, HKMS model was calibrated and validated for the Taluk Shimulbari station at Dharala Basin. And here we can see a figure, the figure number 7, that flood forecasting for Kurigram station by the Flood Forecasting and Warning Center. So here they forecast they forecast 5 days deterministic forecast by predicting the water level or measuring the water level, and here I used to getting qualification to getting discharge, and I also try to show the discharge at Kurigram station for 2019 period. And here we can see that the almost the values are probably underestimate the observed ones, but the following trend is same. Following water level trend is same. So we can say that the WWF predicted rainfall can be used in a hydrological model for produce a accurate flood forecast. Conclusion: in this study has a attempt to get a WWF predicted rainfall, which is very important for flood forecasting. And changing scheme have a great influence for predicting rainfall, and the model performance indicates one physics scheme and one cumulus physics scheme, which is appropriate for predicting rainfall. And HMS model was also developed for coupling with um, the direct predicted rainfall for Dharala Basin. And in this study, the model can simulate for Kurigram gauge station, and the date of simulated peak discharge is also same as the model simulated discharge. And I think the model shows the promising results, which indicates that it can be used in the future for another basin, another large basin like the first question, even
You are
calibration,
muted. Okay.
and we can use for the developed predicted precipitation estimation for in the future aspects. Thank you, sir. Thank you all for patience here.
Thank you. Thank you, Mozilla. I request for the questions.
Manjula, you have done excellent work. But I have some questions. Just before using hydrological model in flood forecasting system, you have to calibrate the hydrological model first. So have you calibrated your hydrological model first?
Yes, sir. I have calibrated.
You didn't talk about the calibration of hydrological model in your presentation, so that's why I'm asking these questions.
Sir, I calibrated it for the flood of 2016, and 10 days simulation were carried. That's time. That's the calibration period.
Okay. So actually, we need calibration and validation before applying hydrological model in flood forecasting system. And I have another question. Just when you run the flood forecast, for example, for today, you have run the flood forecasting for next 7 days. That means you run the WRF model for 7 days. Yeah, you mentioned in your presentation.
Yes.
So you only use the WRF predicted rainfall, or you also use the real-time rainfall data?
So
For
I
hydro
only
period.
used WRF predicted rainfall in the hydrological model, and the observed discharge are then compared with the hydrological model discharge.
But problem is you are always talking about the meteorological aspect, but you never. I think the previous presenter also that always talking about the meteorological perspective, but they do not consider the hydrological perspective, because when you use hydrological model in flood forecasting system, you have to run the handcuff period also, because your every hydrological model always suggest you just skip the first 2 years for the warm-up period. Yeah, because when you run the hydrological model today, hydrological model actually first establish the parameter, because you always the parameter used for canopy or soil infiltration, or a lot of parameter you use in your hydrological model. But when you run the initially, that all the parameters value are just zero, or your land use value, they don't have any water. Okay, so that's why you need 2 years for
I think rather than going into discussion, if you have any specific
okay. Okay, so
Thank you for your kind
you should also the handcuff period also, yeah. Otherwise, you didn't get the better result. Okay. Oh, thank you so much.
Thank you, sir. Thank you for your suggestion.
One more. I think we can welcome one more if there is any. Okay, if not, then why not, Dr. Mondal, we go for the next?
Yeah, the last one.
Last presenter,
Again,
Saria.
Mary, sir, I think his line is okay. Let her try once.
Okay, Saria, we want to see you here.
Merin, কলটা ধরো। Hello,
She is
Merin.
talking about
Pick my
simulation
call.
of radiation fog.
তোমার তুমি কি হেডফোন দিয়ে কথা বলছো? তোমার
We
মাইক্রোফোন
will be
পাচ্ছে না।
patient for a few minutes. Let's wait for. Yeah, Shakawat, you can be a big help if she connect.
Merin, we cannot hear you. That is the problem. So
Neither here
either
nor
your
she, we cannot do anything.
volume is low, or your audio system has some problem.
Can somebody make her presentation instead of her? Is it possible?
Yeah, that is not bad idea. It's good.
So
how would
yeah,
you-
it is a
I
joint
think,
paper.
yeah, actually, I am attached with the, actually, that means research of Saria Meherin. So if Saria
So-
Meherin send me the presentation, then I can do for her. If you allow,
alternately, yeah, alternately she can share and you can speak.
Okay.
okay, you can do, sir. Okay. Saria, you
Saria,
just,
you can share your screen and then Professor will speak.
Saria, you just forward your presentation to me. Immediately I will download and I will display. If you could not do that one.
So we can have some discussion on the papers.
Yeah, in the meantime, there are already we
Yeah.
finished.
So Shadat, you are saying something, regarding the previous presentation. So you can speak now for 1-2 minutes. I understand that they are in the process of learning, so there will be some deficiencies.
Definitely. I think from my side, I talk a lot. Okay, so if the presenters have any questions, we can discuss.
I also have one observation regarding the use of hydrological model. You see, in a hydrological model, we usually get discharge.
Yeah.
But in flood forecasting, we actually need water level also. And
Yeah.
water level is very important for flood forecasting. And
Sir, Sadia Merin sent you the email. Would you please check?
Yeah, I am online. I am trying to check.
Actually, Tupur use the reverse rating curve. That means she gets.
Yeah, I have got that one. I am downloading.
She gets
Yeah,
the distance
I mean,
from
what happens, you
the
see,
hydrological model, and then they revert the rating curve, then they get the water level. Okay, otherwise you have to develop a dynamic model, a hydrodynamic model for the river system for getting the water level data.
So that was actually my point. I mean, rating curve in terms of discharge and water level, one-to-one relation is very difficult. And it varies from year to year,
Yeah,
and also
definitely.
season to season. So to take into those sort of things, actually we need coupled model, what we call hydrologic hydrodynamic
Hydrodynamic
coupling, or hydrodynamic model with input of rainfall.
Yeah,
Then you can
of course,
use for real-time forecasting.
Yeah, of course, sir. Actually, in Bangladesh, flood forecasting warning system, they use the couple model, hydrological and river model. They are couple it and then produce the flood forecast all over the Bangladesh. It's a normal practice in Bangladesh. Thank you, sir.
Yeah, sir, is
The
it
screen
visible?
is now shared,
Yeah,
so we
yes.
can go for
We will go for the next. The
Okay,
last.
so
Yeah.
this is Dr. Abdul Mannan. I am working for Bangladesh Meteorological Department. So
Yeah.
actually, I am associated with the with this research paper of Saria Meherin with others also. So for her, as there is the problem, I am making this presentation. If you allow me, sir, I can continue.
Yes, sir. But we really appreciate if we can see you. as
Okay.
well.
Okay, thank you. The outline of this presentation is actually it has been arranged in such a way that first introductory remarks should be there, then objective study area, and data use, then methodology, then climatological perspective, and then results and discussion. Of course, finally there are concluding remarks also there. So before going to here, actually, as I have the opportunity to meet with you, and I can explain some of the important things regarding the radiation fog, what she studied during her MSc thesis. So fog, there are several types of fog is there. One is called radiation fog, and another one is called advection fog. Some other types of fogs are there. Actually, radiation fog is mainly due to the cooling effect of at the night time and temperature goes beyond the that is called some level so that saturation can be started. with this point of view, actually radiation fog has been studied. And interestingly, the matter is there, due to this radiation fog, aviation activities has been hampered a lot of, especially our areas like Nepal, Bhutan, Himalayan territorial region, as well as in Bangladesh. So we are also suffering this sort of radiation fog situation in every winter season. Now you might be knowing that winter season is going on, and we are having one foggy problem is there. Luckily, this presentation is there, but I am trying to say that the foggy situation, what is right now in Bangladesh, it is not only the radiation fog, it is the combination of both. It is the combination of advection fog as well as the radiation fog. That means this advection, this fog has been generated over the Nepal territory, in the Tarai area, so far my understanding, and South Himalayan West Bengal, and with the lower atmospheric flow, it has been reached to Bangladesh. And due to radiation cooling effect, it becomes deep and deep at the night time. That's why this foggy situation in the last 3 to 4 days is happening. And accordingly, as far as of the interesting information available with us, it will continue some more time also. Once the origination point will be disappear, that means will not be favorable for formation of further fogging, the things will be dissolved in our territory also. That is my submission. Thank you, sir, for allowing me this explanation. So this is the introductory remarks. This fog is an weather event. It becomes very dangerous, especially in the case of transportation, like airport transportation, aircraft transportation, like road transportation. Even it is very dangerous for the riverway navigation and seaway navigation. Also, with this aspect, this has been taken into consideration for understanding and to give the idea. And you see, as per the classification, it has been defined in different classes based on the visibility. That means how much transparent the lower troposphere is, where we are locating, where our horizon is there. That is light fog, moderate fog, dense fog, and very dense fog. And objective is there to simulate the dense fog event using WRF-ARW model, then to compare the simulated temperature, dew point temperature. That is what I am trying to say during that period. Relative humidity and other important parameters, as well as wind speed is there. Once wind speed becomes very low, beyond 2 km/h in speed, the foggy situation also are being appeared in most of the cases. And accordingly, some simulation has been conducted with using WRF model, and the result, of course, will be displayed to you. So for the study, actually, it has been taken into Dhaka International Airport. The airport name is Hazrat Shah Jalal International Airport right now, and location is already there. And some information and data has been collected from the archive of Bangladesh Meteorological Department, as well as some other relevant resources. So I already told some for numerical modeling, that is WRF modeling, some GFS FNL data has been collected, and accordingly based on the initial condition and boundary condition, warp model has been run to see how it is performing with the foggy condition, how it provides the information, whether really, as per the model, the temperature and dew point temperature are becoming equal or not, and how much relative humidity profile is there, whether any advection is necessary is there, or whether any that means radiation facility, radiation filling facilities are there or not. This sort of things has to be understood through this numerical modeling. So this is the model domain. You might have seen at other places also. Domain, they have taken 3 nested domain, 3 nested domain, and it is outer domain, and this is the inner domain. But inner domain is a one-way. Innermost domain is the one-way nested, and it is 1 kilometer in resolution. And of course, some other peripheral activities are there, and grid analysis and display system softwares are being utilized for displaying the model production, other relevant informations. So this is the model features. So many informations are there. With the inbuilt physics facilities has been incorporated in the modeling technique, and of course microphysics WSM6 that has been taken, and third order Ranscutter technique and other inbuilt techniques has been considered for this model. So similarly, some other information has been collected, as I already told, that the fog events during the visibility and temperature, as well as dew point temperature, as well as relative humidity. This situation is there, and it has been tried to collect the information how long it has been continued over the airport region and adjoining area. Also, this sort of information has been collected, and similarly, some other information has been collected how aviation sector has been hampered with this foggy situation. Not only at Dhaka airport, some other airports are also being hampered with these aviation activities, and people have to wait for a long time in the airport also. So this sort of situation has to be taken into consideration for understanding the impact of the foggy condition over Bangladesh as well as other places. So this is one of the left side is one of the synoptic features has been extracted. The picture has been collected from Bangladesh Meteorological Department. Actually, it is a surface level information analyzed through different international internationally standard technique, that the isobaric technique is there. And here we found that over Bangladesh territory, there is the low pressure system. It's not a sea originated low pressure system. It's a low pressure system that is popularly known as thermal low. That means Dhaka territory and adjoining area is comparatively are having higher temperature as well as lower pressure than other surrounding area, and it has been given the initialization of the foggy situation, means it has been carried sufficient moisture at the lower level so that it has to be condensed due to radiation at the night time. Actually, this sort of things has been taken. If it would be the high pressure system, there would be the divergence facility and moisture had been carried away from that place. So there is the less chance of foggy situation over that particular day or particular period. This sort of things has been taken into consideration. The numerical modeling has been taken, and here you see through this model, the cloud fraction, mean sea level pressure, height and 10-meter height wind as the standard measurement level of Bangladesh worldwide to the meteorological services, and then cloud fraction and other information has been collected and analyzed. And then you see time series of the visibility. That is the most important, as I already showed in the previous slides. As per classification, once the light fog is there will be no problem with the aviation and other sectors. But if the fog is becoming very dense, it may be 100 meters or less. In that case, aviation sector is badly hampered. Nobody could go move, no aircraft can move, no navigation can be possible even during that period. So that's why a foggy situation has been taken, and here you find that from 19 UTC onward, the visibility has been becoming decreasing, and from 21 UTC to the 3 UTC of the next day, it was continuing. That is zero visibility is there. That means the aviation during that period are badly hampered. And you see what is the relative humidity? It has been very near, or it has been very close to 100%. And you see what are the temperature and dew point temperature, both can be together, and you see both are the same values, almost same values, maybe 0.1 difference or may not be differences. And then you see there are the wind speed is becoming less, that means minimum, that means zero. As I already told, this sort of information is very much favorable for prediction as well as for understanding the fog facility, fog formation, fog continuation and disappearance. This sort of things would be there. Similarly, some other information already have been taken into consideration during the 24 to 25 December 2019. From the numerical model, it has been that both the values are there, the temperature and dew point temperature, and other facilities what we have been collected through this simulation and found that what was the relative humidity, wind speed was there. So model, as per simulation of the model, I already told the minimum wind speed was less than 2, and we have got the less than 2. And relative humidity, I think there might be mistake over here. I think this must be the temperature and dew point temperature, some other things. It must be very near to the dew point temperature point. So again, we see what are the spatial distribution of foggy situation as per the numerical modeling. So at the beginning period, what we found, there is more foggy situation is not there. Then it has immediately becoming, it has started to appear. then it has been extended and expanded, and then it has been continuing for some hours, even like today over in Bangladesh. In some days, it has been continued day long, 2 to 3 days, 4 days, 5 days also. These sort of things are there. Similarly, in the case of other 14 to 15 January 2020, here you see this situation is there. Visibility is becoming very low, very near to zero, maybe 10 meters or less. And you see the visibility as well as the pressure, interesting point, during that feature, pressure becomes very high. And other features also very famous, favorable the fog formation situation. Let's see, at fog, is it the surface phenomena? No, it is not only the surface phenomena, it is also the lower tropospheric phenomena. That's why we need to see the vertical profile of temperature, vertical profile of relative humidity. As relativity 100% is the most favorable condition, we have to see how much height it would continue for that day during that period. Even we have to check what are this relative humidity profile before the foggy day and after the foggy day for making it predictable in nature. That's why this sort of thermodynamic diagram has been plotted and as well as carried out and as well as has been analyzed. And accordingly, what we found that in the lower troposphere, up to 300, in some cases up to 500 hectopascal, 500 meter height, this enormous amounts of relative, that means moisture was there, that were supposed to be condensed for fog formation over that particular area. That means moisture availability is a must. If it would not be there, atmosphere would be sufficiently dry, no temperature cooling condition condense the moisture content to become a foggy
Dr.
condition.
Manan.
Yeah, I am closing, sir. Thank you. So I think whatever things I have already discussed, Saria Meherin, if it would be in my place, I think she could explain it in a better way. Thank you, sir, for giving me chance. Thank you.
Thank you very much, sir. There are already 3 questions in chat box. First one is, what remedial measures can we suggest to get rid of fog?
Yeah, shall I answer right now?
Yes, it is.
Okay, so important thing is actually, first of all, we have to make this predictable in nature. One thing, we have to make prediction well ahead of time, which that means for taking precautionary measures, we have to provide sufficient lead time. It may not be within day, it may be 3 days or more. If this sort of lead time would be there, aviation authority could take proper measures for their purposes for the betterment of aviation services. Next, come to
Mozilla,
the point. Yeah.
Next question is from Mozilla, is asking about, I have a question regarding validation of simulation result.
Yeah.
And again, there is another question from Mohan. Mohan is asking about the difference between model simulated as well as observed visibility.
Professor Deepakji,
Yes, please.
hello.
Yes, please. You can ask by yourself. Yeah.
Okay, thank you very much. Actually, very nice talk, and I think this is the one of the first initiative in Bangladesh to simulate the model simulate visibility and compare with the available observation. So, of course, model has some limitation. So, could you please tell me how it differ and how it can be improved? Thank you, Manan.
Yeah. Thank you, Dr. Mohan. Actually, okay, I am regarding validation. What I am telling at this stage, as Saria Man is the MSc student, she has to complete her research within 6 months. That is the optimum time, not more than more time would be allowed for her. So what we do, we have selected few events to simulate, but to make it in a formulation, we have to have several events and to make a comprehensive analysis and to do that one. And we have to check whether model is really performing as per optimum level or not, or model have some deviation which can be considered in the study and to make it in a formulation process. Say model is always giving the less visibility, but we have to add 100 meter more visibility to check that to get the optimum visibility to the observed visibility. In that way, we have to check in every parameter especially visibility, especially wind speed, especially pressure, and especially some relative humidity, as well as the lower tropospheric profile of the atmosphere, as well as we have to check the surrounding features. Yes, is there any facility for coming moisture content from other sources or not, or it will come only from the single source. This sort of things has to be there, because the airport case, Dhaka airport is in a flatland. In the case of Chittagong airport, the facilities would be in different, environment would be in different. If it would be in Kathmandu airport, the facilities would be in different. And if it would be the Bhutan airport, that would be a further difference. So we have to check in that one. First, the case has been started with the Dhaka airport. I think Sharia Marin will continue her research with other airport places, and then she could be able to make a comprehensive activities for utilizing in prediction and other purposes. I think one more question was there. Let me check. What was the validation? Actually, validation is a mandatory part of every analysis. I think one IWM person rightly mentioned about that one. I do agree with him. But even though here you see the validation has been taken into the result and study, but it may not be included in the presentation, because every student or every of us, this morning also I have a presentation. Once we make a presentation, we are always afraid of. We are trying to hide something from the senior person, so that they could ask many questions. These sort of things we are inherited for since long. Now people are coming forward and they are doing more and more works. I think the things will go, but of course the validation will be there and validation should be there. Thank you.
Okay, now there are some more questions. We can interact later on, and we will come in. I will ask the organizer to pass their Sharia's email, so that those who have questions, they can ask for Sharia by themselves. So next turn is we both, co-chair and I, need to give some concluding remarks. Just before that, I would like to request switch on the video. Everybody, if they switch on the video and someone from the organizer take a snap for everybody, this will be a good picture for future University of Dhaka Department of Meteorology for their records. So please switch on the video for a minute. It's not necessary to switch on them. It's not necessary to unmute you, but it's just switch on the video. And can the organizer, any of you, can take the picture of all of us? Now I'm looking the Sharia. Sharia is also here now. Good afternoon, Sharia. Okay, I think we have a photograph. Then I would like to request my co-chair, Dr. Monan, for his concluding remarks.
Thank you, sir. Honorable chair of the session, respected presenters and authors of the papers, dear participants, organizers, guests, a very good afternoon, though I should have said it at the beginning, but I was a little late, so a very good afternoon to you all. It gives me an immense pleasure and honor to be present here today to co-chair this session. You all know that we live in such a geographical area where we have multiple hazards and multiple vulnerabilities. We live with floods, drought, erosion, cyclone, storm surge, and many other hazards and vulnerabilities. Recently, we have noticed that landslides, thunderstorms, hails, fogs have increased. very much. And very often it is said it is due to global warming induced climate change and variability. So the presented 5 papers, I would say that very much in line with these hazards and vulnerabilities. And we must have benefited in terms of new knowledge, new tools, new techniques, and that this will help to mitigate our future hazard and improve our disaster management system. I found all the paper very interesting, particularly 2 papers on drought. They are, well presented, and there are a lot of works behind these 2 papers. And also the last paper on fog, I find it very interesting, and particularly the data and the model. This is very interesting to me. The other 2 papers on flood or runoff, I think there were some comments, and in the team there are some young members. They can take it on board, and I hope they will improve based on the comments and questions they have received, and I encourage them to publish their works in reputed international journals. Once again, I thank the organizer for inviting me to co-chair this session, and also particularly to thanks to Professor Dr. Tauhida Rashid, who is the chairperson of the department and also the convener of this conference. I also thank Mr. Shourab. He was continuous in touch with me regarding this conference. So thank you all, and wish you all a safe stay. Thank you.
Thank you, Dr. Mondan. So before concluding, once again, I would like to say you salam alaikum, namaste, and good afternoon. Staying at home, we have been able to successfully conduct this wonderful conference. First of all, let us congratulate Professor Tauhida Rashid and her team at Department of Meteorology, University of Dhaka. And second, I would like to thank, I feel I am very much honored to chair this session. Thank you for the organizer for giving me this wonderful opportunity. In these 5 papers sessions, we have all numerical, modeling, insight measurement, as well as satellite-based data systems information. We got that kind of information. As we know that Bangladesh, Nepal, as well as India are mostly vulnerable with so many meteorological disasters. There are so many observations around this area. If we consider this observational data based on your numerical as well as modeling work, as well as satellite-based informations, so we may get some benefit to forecast this disaster before it will happen. So in my concluding remark, what I can say that is that for that, we need to have a collaboration between several organizations, those who are working in the field of meteorology as well as hydrology and disasters. So let us let's be together with us in between Bangladesh, University of Dhaka, Department of Meteorology, and us in Central Department of Hydrology and Meteorology at Tribhuvan University in Nepal. We are working together since maybe a year back. 2 of students came to our department for their intern work. Unfortunately, what I was expecting, they didn't get that kind of facility, but I hope they enjoy staying in Nepal even in the COVID period. And within 4 months, they have been successfully able to get their home in a rescue flight. With this, once again, thanking the organizer as well as Professor Tauhida ma'am for giving me this opportunity. I would like to conclude this session, and I hope I can see these 5 papers in some open literature as soon as possible. Let us congratulate all. Thank you very much.
Thank
Bye.
you, sir. Thank you, sir. Thank you all.
I would like to thank Honorable Session Chair and Co-Chair to conduct the session and the participant for their presentation. Now I would like to thank all the audience to attend this session. The next technical session of the conference will be start at 16:30 in Bangladesh Standard Time. So all are invited to join the session. Thank you, everyone.
Thank you.
Thank you.